I look at that picture and all those dots look the same to me. So tell me, why tell me about this picture that we just saw showing the comet? Well, there were no new insights as to the properties of this object from this NASA press conference. They pretty much repeated things that we already knew. We knew about the Hubble data, the Webb telescope data. And then the new data, for example, the image from the HiRISE camera on board the Mars Reconnaissance Orbiter that should have been the sharpest that we have, just showed the fuzzy ball of light similar to the Hubble image that we already saw before. And there was some data from MAVEN on Mars that indicated hydrogen, but these are details. Nothing in the big picture changed, and the point is that the presenters should have emphasized what we don't understand rather than insist about what is familiar. And as I say, that the foundation of science is the humility to learn something new rather than the arrogance of expertise. That's what the public resonates with. And I pointed out 12 anomalies about this object. NASA finally revealed its long-promised images and data on 3 Atlas during a widely anticipated press event. The agency presented new observations from multiple spacecraft and telescopes, offering the public an official overview of the interstellar object's current behavior and characteristics. For many viewers, the event may have seemed thorough enough. A coordinated presentation, clear messaging, and authoritative commentary giving the impression that the object fits comfortably within known cometary behavior and poses no scientific surprises. But Avi Loeb is less than impressed. In fact, what NASA presented was almost exactly what he predicted in advance. There wasn't much news, I must say. An hour before that press conference I was asked by a reporter what do I expect, and I said I don't expect big news and NASA will repeat the official mantra that FIA Atlas is a natural comet and that they were unable to process the data until now because of the government shutdown, and probably the HiRISE image will show a fuzzy ball of light like the Hubble image, but I hope to be surprised, and I was not. Oh man. But we did see a new data, but nothing major in terms of the insights as to the nature of the object. There was data presented in addition to the one we already saw from the Hubble Space Telescope, the James Webb Space Telescope's FAREX Swift. These are things we already witnessed. There was some new data from the Lucy spacecraft, MAVEN, SOHO HiRISE. But again, all these images were fuzzy. There was no new insight offered by them. He said he hoped to be wrong, that perhaps NASA would provide sharper data or acknowledge the unresolved questions that had been circulating for months. Instead, the event unfolded exactly as Loeb had warned it would. The explanation stayed firmly within the safe, expected narrative, and the imagery offered little meaningful progress in understanding the object's true nature. What troubled Loeb most was not just the lack of new detail, but what wasn't addressed: a body that appears far larger than any previous interstellar visitor, a chemical profile that includes nickel without iron, something not found in known natural comets, and jets that remain tightly columnated and unmoving even though the object rotates every 16 hours. Behavior that defies standard comet physics. These are not minor curiosities. They are deep structural anomalies. Yet NASA's briefing barely acknowledged them. Meanwhile, amateur astronomers continue to capture strikingly detailed images of 3 Atlas with equipment that costs a fraction of NASA's instruments. Their footage reveals multiple jet structures, rapid changes in brightness and dynamic surface activity. Visual evidence that stands in stark contrast to the subdued, carefully curated visuals shown during the official presentation. This widening gap raises pointed questions. Why are independent observers seeing more than the world's leading space agency is willing to show? Is NASA afraid of classification? Are they trying to avoid public panic? Is this bureaucratic damage control or preparation for something bigger? NASA's reluctance to address these anomalies head-on creates a sense of scientific whiplash. The official narrative insists that everything is normal, while the data, both independent and observational, keeps whispering that something is deeply off. And this is where Avi Loeb's broader concerns come into focus. He's not asserting alien origin, nor is he pushing sensationalism. What he's pushing for is honesty, a willingness to treat anomalies as meaning rather than inconvenient. If 3 Atlas is natural, he argues, then it forces a re-evaluation of how interstellar objects form. Its sheer mass, peculiar chemistry, improbable trajectory, and atypical jet mechanics would each demand updates to astrophysical models. Together, they pose a challenge that cannot be dismissed with a shrug and a press release. By ignoring these clues, NASA risks missing the very discoveries that drive science forward. At the center of this growing tension is the size of the object. Based on brightness curves, thermal estimates, and reflected light analysis, Loeb suggests that 3 Atlas may be 5 kilometers across or larger. If true, the object is dramatically more massive than any interstellar visitor humanity has observed. The first recorded interstellar object, AMUA, was barely 100 m long. The second Borisov measured around 1 kilometer. Statistically, the third one should have fallen somewhere within that rough range. Instead, it appears to be orders of magnitude larger. This massive discrepancy is not a minor footnote. It is a statistical impossibility under standard models. If interstellar traffic contains objects this large, the number of smaller ones should be exponentially higher, millions more. Yet, none have been seen. This inconsistency alone demands further scrutiny. Then comes the composition. The detection of nickel without iron is a glaring red flag in astrophysics. Stars forge these metals together, always with iron being more abundant. Natural bodies, comets, asteroids, moons inherit this ratio. 4-3 Atlas to contain nickel, but almost no iron defies known cosmic processes. Loeb refrains from dramatic conclusions, but he does point out an uncomfortable truth. Nickel-rich iron-poor mixtures are deliberately manufactured on Earth for specialized industrial uses, especially aerospace applications requiring strength and heat resistance. He does not claim this to be evidence of technology, but he does insist that NASA acknowledge the chemical oddity rather than sweeping it aside. Ignoring such an anomaly is not science, it is denial. Another layer of mystery is the jet behavior. In typical comets, jets erupt from localized hot spots as sunlight warms volatile materials beneath the surface. These jets twist, wobble, or shift as the nucleus rotates, creating arcs and spirals that reflect the comet's spin. But 3 Atlas behaves differently. Its jets appear rigid, stable, and tightly focused, almost as though they are being columnated by a mechanism rather than erupting passively. Even as the object completes a full rotation every 16 hours, the jets show almost no variation in orientation or shape. Amateur video sequences highlight this strange rigidity. Instead of swirling or pivoting, the jets behave like fixed beams extending thousands of kilometers. NASA did not mention this in the press event. Even though it is one of the most visually unmistakable anomalies associated with the object, the trajectory deepens the puzzle. Interstellar objects should approach the solar system from all sorts of inclinations given the random motions of stars. Yet 3 Atlas arrived almost perfectly aligned with the ecliptic plane, the flat region where the planets orbit. Loeb estimates that the odds of such alignment occurring randomly are roughly 1 in 500. This means the object entered the solar system along the exact path that maximizes visibility for human instruments. NASA framed this alignment as good luck, but statistically speaking, it is an outlier that begs for explanation. If the object were artificial or guided, such a path would make sense, but even under natural interpretations, its alignment is extremely suspicious. Loeb does not claim intention, but he insists on acknowledging improbability. NASA's silence on this peculiarity is conspicuous. Some scientists like Michioku lean on age as a potential explanation. If the object is 7 billion years old, older even than our solar system, it could have accumulated unusual materials, weathered diverse cosmic environments, and undergone transformations we do not yet understand. Over vast time scales, chemical and structural changes might appear exotic to us simply because we lack comparable examples. Kaku suggests that the object's oddities may be the result of unimaginable antiquity rather than artificial design. While Loeb accepts that age could explain some features, he contends that it does not resolve the most puzzling ones: the disproportionate size, the lack of iron, the straight jets, the improbable alignment. Age alone cannot carry that weight. Another point of tension is the delayed release of data. NASA held back the high-rise image for over 6 weeks, citing the government shutdown, even though other Mars imagery flowed freely during that period. The inconsistency plays poorly with the public, fueling speculation that NASA was withholding information. Loeb attributes the delay not to conspiracy but to bureaucracy. The desire to have everything pass through administrative channels rather than scientific urgency. Yet this interpretation, while charitable, does not change the fact that transparency was sacrificed. In moments when scientific clarity matters most, NASA chose caution. That choice now casts a long shadow. As 3I Atlas approaches Earth, the opportunity for clarity grows exponentially. Over the next year, the object will brighten steadily as it travels along its inbound trajectory, making it increasingly accessible to mid and large aperture telescopes across the globe. By the time it reaches its closest approach in December 2025, a distance projected to be roughly 0.2828 astronomical units or about 26 million miles, astronomers will be able to observe it with far greater resolution and sensitivity than anything achieved to date. Instruments like the Very Large Telescope in Chile, KK Observatory in Hawaii, and Japan's Subaru telescope will be capable of capturing detailed spectra across ultraviolet, visible, and infrared wavelengths, allowing scientists to isolate and quantify the precise chemical signatures emitted by the objects, and jets. These spectra will reveal whether the nickel-heavy iron-pore ratios persist under higher resolution and whether additional anomalous elements or compounds are present. Simultaneously, space-based observatories including Hubble, JWST, and possibly the upcoming Roman Space Telescope will have unobstructed vantage points to obtain high-precision photometry and surface texture imaging. JWST's NISPC and MIRI instruments in particular could resolve thermal gradients across the object's surface, identify molecular outgassing patterns, and map the temperature distribution of the jets, helping determine whether they arise from natural sublimation or from a more exotic source. The European Space Ice Gaia spacecraft may contribute astronomical measurements with microarc-second precision, refining calculations of the object's non-gravitational acceleration, if any, and determining whether its trajectory deviates from that of a purely passive cometary body. Ground-based radio observatories will also take center stage. The Atacama Large M/S submillimeter array, ALMA, can detect faint rotational transitions of trace gases, providing molecular fingerprints that even optical telescopes cannot capture. The Meerkat Array in South Africa and the Greenbank Telescope in the United States may once again search for radio emissions, improving upon the earlier November 5 upper limit findings, which ruled out transmissions above the power of a mobile phone at the observed frequencies. If any structured or repeating radio signals were to appear, these facilities would detect them. Perhaps most importantly, the global network of amateur astronomers, the same observers whose early images outperformed NASA's official releases, will have unprecedented visibility. Thousands of coordinated amateurs will track the object nightly, documenting changes in jet morphology, brightness variability, rotational period, and surface activity. With modern stacking techniques, off-the-shelf telescopes can now achieve signal-to-noise ratios once limited to professional observatories. Any inconsistent behavior, sudden jet reorientation, surface fragment shedding, or rapid changes in trajectory will be spotted within hours. If 3 Atlas behaves like a typical comet, the observational flood of late 2025 will make that abundantly clear. Sublimation patterns will match known thermodynamic models. Spectral fingerprints will align with familiar volatile compounds. Jet behavior will correlate with rotation. The object's mass, density, and brightness will settle into predictable relationships. But if the anomalies deepen, if the nickel-iron imbalance persists, if the jets remain mechanically straight, if non-gravitational acceleration emerges, or if new patterns appear that defy natural explanation, then the inconsistencies will be visible to everyone, not just government agencies and university labs. For now, the divide between NASA's calm assurances and the mounting body of puzzling observations remains wide. Amateur astronomers continue to document phenomena that appear increasingly inconsistent with ordinary comet behavior. Independent scientists ask questions that NASA seems unwilling to address. Lowe stands firm in the middle of this widening gulf, urging openness and exploration rather than premature conclusions. He understands that bold claims require careful evidence, but he also recognizes that dismissing anomalies outright is unscientific. What happens next depends on what new data reveals. If 3 Atlas is natural, then it represents a category of interstellar objects unlike anything previously documented. A revelation with its own profound implications. If the anomalies deepen, the NASA will face pressure to revise its narrative. And if any evidence, however faint, suggests technological origin, humanity may be on the edge of a discovery that reshapes its understanding of the universe. Until then, Lowe insists on one thing: paying attention. Ignoring the unknown is easy. Investigating it is harder. But progress, he argues, depends on the courage to follow the evidence wherever it leads. And if 3 Atlas is as strange as it appears, the evidence may lead us somewhere no one expects.